Dear students, today I am going to deal the Unit 3 High Altitude under Environmental Physiology, the paper code PEN 18CT 301 under the program MSc Exercise Physiology and Nutrition. The learning objectives. The purpose of this course is to familiarize the student with environmental or ecological physiology in human. This discipline is principally concerned with how human beings are physiologically adapted to the environment. Another objective of this course is to enable the student to apply knowledge about physiology and adaptation to identifying appropriate questions for research and correctly interpreting data. The learning outcomes. The student knows the principles of human environmental physiology and how an individual obtains and maintains the homeostasis at molecular, cellular, and tissue levels in the context of changes in the surrounding environment and physiological changes and acclimatization. This picture, if you could see, you can find various kinds of altitudes from sea level to the extreme altitude. What is high altitude? From 5,000 feet till 8,000 feet is said to be high altitude. From 11,500 feet to 18,000 feet is very high altitude. And the extreme high altitude is from 18,000 feet to 30,000 feet. And this is the graphical representation of altitude in kilometer and atmospheric pressure in mmHg. If one ascends to Mount Everest, how the atmospheric pressure is decreased and the partial pressure of oxygen also decreased. So, at sea level, the atmospheric pressure is 760 mmHg, wherein the partial pressure of oxygen is 160 mmHg. So, one ascends to 29,035 feet. The atmospheric pressure will be 250 mmHg and the partial pressure of oxygen is 53 mmHg. What is barometric pressure? The barometric pressure and atmospheric pressure are the same. So what it means? The density of the atmosphere, which varies according to altitude and weather conditions. Barometric pressure and partial pressure of gases. The barometric pressure at sea level is 760 mmHg and the partial pressure of oxygen in atmospheric pressure is 159 and in alveolar air the partial pressure of oxygen is 104 and the partial pressure of carbon dioxide is 40 and the percent oxygen saturation of hemoglobin is 100. So, one ascends to 5,000 meters, 10,000 meters, 15,000 meters and reaches to 40,000 meters. Where in 40,000 meters, the barometric pressure reduces to 140 and the partial pressure of oxygen is also reduced in atmospheric pressure is 30 and the partial pressure of oxygen in alveolar it is 12 and the partial pressure of carbon dioxide is 24 and percent oxygen saturation of hemoglobin is 15. What is a barometer? This is a device used for measuring atmospheric or barometric pressure. The pressure acts on the basin containing liquid, driving the mercury levels in the tube up or down. Evangelista Torricelli, an Italian physicist, developed the first mercury barometer in 1643. What is high altitude? The height above 10,000 feet, that is 3,000 meters above the sea level, is defined as high altitude. According to Dalton's law, the total pressure of air is equal to sum of partial pressure of gases it contains. So, what are the partial pressure of gases? That is oxygen, carbon dioxide, nitrogen, and as well as the water molecules. So, P is equal to PO2 plus PCO2 plus PN2 plus PH2O. Here PH2O and PCO2 does not depend upon altitude, but the PO2 and PN2 decreases with increase in height. At high altitude, the low partial pressure of oxygen leads to hypoxia. What is acclimatization? It refers to changes in body tissues in response to long-term exposure to high altitude hypoxia, such as when a person living at sea level goes and stays at high altitude for a long time. What are all the changes in the body, especially in blood? It increased hematocrit to 60% and increased hemoglobin concentration to about 20%. And since increased erythropoietin secretion from kidney, the increased RBC count as well as the hemoglobin concentration is increased. What are all immediate physiological changes in high altitude? The immediate physiological changes that occur in an altitude in response to decreased oxygen content of the atmospheric air. What are all the changes? 1. Increased rate and depth of breathing. Secondly, increased production of red blood cells. Thirdly, increased renal excretion of bicarbonate in response to respiratory alkalosis. What are all the other acclimatization at high altitude? Various physiological readjustments and compensatory mechanism in body that reduces the effect of hypoxia in permanent residence at high altitude. For example, the Ethiopians who live in a higher altitude where their physiological adjustments are happening every day since they are living years together and they train in a higher altitude and where their physiological systems are developed, such as a great increase in pulmonary ventilation, increased diffusion capacity of lungs, increased ability of the tissue cells to use oxygen, and increased vital capacity. When these physiological systems develops, automatically they run and complete the task of running more than 10 kilometers, 20 kilometers, even the marathon race. So they win the prizes in Olympic as well as in world competitions, especially in athletics. What are all the other physiological adaptations? When partial pressure of oxygen is low, in alveolar and arterial hypoxia also is low, and in tissues also the partial pressure of oxygen is low. So how the demand of oxygen is met? That is by rising the cardiac output and pulmonary ventilation, the demand is being met. And another physiological adaptation is erythropoietin from kidney. It secretes from the kidney and thereby it increases the RBC count as well as the volume of RBC, and the hemoglobin concentration also increases. The hormones such as glucocorticoid and vasopressin will counteract to the hypoxic stress. Then hemopoietic and cardiovascular system, the respiratory system, the central nervous system will all have changes, and adaptational changes are happening in these systems. Thereby, one can withstand for in the higher altitude, that is the low partial pressure of oxygen. Thank you very much for your listening. I hope you would have understood regarding the different kinds of altitude and what is the atmospheric pressure in the different altitudes, what are the partial pressure of oxygen when one ascends, how it is been decreased, and what are all the immediate physiological changes happening one ascends, and what are all the uh, physiological adaptations taking place when one who trains in the higher altitude. So thank you very much once again. Thank you.